Hello everyone, my name is Swam Siddha Sahu. Welcome to my presentation on domain, range and codomain in relation. So what do you mean by relation? Practically in everyday life, we pair the members of two sets of number. So this presentation deals with the linkage pair of elements from two sets and then introduce relation between the two element in pair. For example, a teacher often pair each set of score with the number of students receiving that score to see more clearly how well the class has understood the lesson. For example, a relation is a subset of Cartesian product. That means a relation R from set A to B is a subset of Cartesian product of A cross B. That means a set A contains A, B, and C, and set B contains a few names such as Amit, Bittu, Bholi, and Don. If we define their Cartesian product A cross B, that is A Amit, B Bittu, A Bholi, A Don, B Amit, B Bittu, and so on. These are the elements of A Cartesian B. So if we create a relationship or relation from set A to B where A and B are only start from their names, such as the names of set B are denoted with A and B only. So here the relation is A Amit, A Bittu, A Boli, dot up to B Don. Not included the C one because we excluded it. So this is a relation from A to B where all the names are denoted with A and B only, not C. If we come to the domain part, what is domain? Domain is a relation in the set of all possible inputs value. It defines the value that can be used in a function. So domain is the all possible input value. So before we study about a group A and group B. So here group A is the input value and group B is the output value. So what is domain? Domain is the group A which is input value A, B and C. So in relation we include the A and B and C is excluded. So here the domain is A and B. So domain is A and B. What is range? Range is the actual set of values that the function produces from the input in the domain. It is the subset of codomain and gives insight into the function real input behavior. That means range is the possible output value. For that relation, we assume the A, B, C, Amit, Bittu, Boli and Don all are included. But if we define a relationship from A to B where all name starting from alphabetical order A and B are included and rather than are excluded. So for that the range will be Amit, Bittu and Voli. Don will not be included. So Don will not included. So here the range will be Amit, Bittu and Voli from set B. Next, what is codomain? Codomain is a set of all possible output value that a function can theoretically produce. It includes all the values that could be mapped from the domain, even if they are not actually achieved in the relation. That means if there is no relation or the Cartesian product, all the all the output value will be the codomain, will be codomain. So all the output value will be codomain. Next is a relation representation. A relation may be represented by a roster form, set builder form, or arrow diagram. Just like a set is A, which is 1, 2, 3, 4. If we define a relation from set A to A, where uh, x x is equal to y plus 1, that is equal to, the set will be 2, 1, 3, 2, and 4, 3. That means if for y is equal to x minus 1, so that for y is 2, x is value is 1. For y is 3, x value is 2. For y is 4, x value is 3. This is the relation. An arrow diagram means, no, in roster form, this. Our relation R is equal to xy such that y is equal to x minus 1. This is the roster form. And an arrow diagram is the diagram where we write the set below like this and we arrow the relation. So here range is 1, 2, and 3, and domain will be 2, 3, and 4. The input value are domain and output value are range. And the codomain is all the possible outcome, that is 1, 2, 3, and 4. A problem. Let A is equal to 1, 2, 3, 4 up to 14. Define a relationship R from A to A by R is equal to xy such that 3x minus y is equal to 0, where x and y belongs to A. So x and y belongs to A set, where 3x minus y is equal to 0. That means y is equal to 3x. So relationship R is equal to x or 3x. That is equal to R is equal to 1 by 3, 1, 3, 2, 6, 3, 9, or 4, 12. Next one will be not possible because up to 14 will be there. So if x is equal to 1, y is equal to 3. If x is equal to 2, y is equal to 6, and so on. But if x is equal to 5, y is equal to 15, which is excluded the set. So that fifth one will be not possible. So here the domain is equal to 1, 2, 3, and 4. These are domain, this input value, and range will be 3, 6, 9, and 12, the output value. And the codomain will be all possible outputs that y can get. So it is 1, 2, 3, 4 up to 14. Next is number of relation. How do we identify the number of relation? Number of relations means if it is a number of possible subsets of A cross B. We will define a number of possible subset of A cross B. That is, if a set is 1 and 2 and B contain an element of 3, B contain element 1 which is 3. So number of element of A is 2, number of element of B is 1. So number of element of A cross B is 2 into 1, that is 2. So number of element, if we generalize the formula, number of element of a P, number of element of A is P, number of element of B is Q. So number of element of A cross B is P into Q. So number of subset is equal to 2 to the power PQ, which is 2 to the power 2 is equal to 4. We conclude that the formula is, if number of element of A is equal to P and number of element of B is equal to Q, then number of element of A cross B is equal to PQ. Thus, the total number of relation by subset is equal to 2 to the power PQ, which is 4. If we define it manually, then A cross B is, how many elements are there? This 3 is 1, 1, 3 is 2, 2, 3 is 3, 5, 5 is 4, and all these elements are with group. So these all 4 are the subset of relation. So this is all about the relation codomain. range and domain of relation. Thank you.